Hi doctor, it's really cold day today. Take a guess how many people will visit our hospital because of the weather?
Oh well, Kate, actually we can estimate it by using the Markov jump process.
What is Markov jump process?
Markov jump process is a continuous time-space Markov process with discrete state space, and it is very similar to Markov chain while Markov chain has discrete time space. Both Markov jump process and Markov chain are particular types of stochastic process, and stochastic process is the one that recognizes the random nature of variables. Markov jump process can help us to estimate the probability that a person moves from state health to state sick and moves from state sick back to state health. It also can give us an estimated time that a person will spend in each state.
Okay, how do we use it to estimate, doctor?
Firstly, we need to know the fundamental of Markov jump process is the transition intensity, which is the limited function of transition probability with a short time period, and it is simply the instantaneous change of the probability changing from one state to another state during the short time period. In our case it is the probability from health to sick. Within a short time period, approximately the probability of changing from health to sick is equal to the transition intensity. Also we need to notice that the sum of the transition rate is 0 because of it is the rate of probability. Or more accurately we can introduce Chapman-Kolmogorov equation into Markov jump process. In Kolmogorov equation, we introduce intermediate states which are the probability of moving from state I to state j equal to the sum of the probability move from state I to all the possible intermediate state k times the probability move from state k to state j, and we derive backward equation and forward equation, which is the change in probability equal to the probability times the transition intensity.
What's the difference between these two equations?
In forward equation we know the probability a person leave their current state and we want to know the probability distribution of the state at the later time, while in backward equation we know the probability of a person that get to their target state, and we want to know the probability distribution of state before he moves to the target state, which in our case the target state is sick. And the integrated form of forward and backward equation will give us the probability that a person move from state health to state sick. Once we figure out the transition intensity we need to find out the holding time, which is the minimum time that a person spent in a particular state. In our case we want the holding time of health. Notice that the holding time has exponential distribution. And once we know the holding time and times it by the transition intensity, then we can find out how many people will move from state health to state sick, which is what you want.
Is the Markov jump process accurate?
Well, it is a good model to use, but as we know, every model has their limitation. Markov jump process inherits the Markov property, which is the future state can be predicted from its present state alone without any reference to its past history. In other words, the past history is irrelevant to the future state, but this may not be the case in practice. For example, if a person had a surgery and turned back to health state, he is likely to have higher probability to have surgery again than other people. And the Markov jump process may not recognize this.
Thank you, doctor. That is interesting, but I have to go back to work now. See you later.
You're welcome.